weather, warm air central heating is the ideal way to heat property. It can provide warm and comfortable conditions quietly and efficiently, at less cost to the customer than many other systems. So why is this woman almost as cold inside her house as out? Why isn't her warm air central heating system working efficiently? This video is the first of 2 parts, showing you how to identify problems and put them right. This first part will show you how to carry out a number of simple checks and adjustments that will improve performance. And part 2 will show you how to balance the system. The 2 types of unit we are going to cover are the old basic controlled heater and the mod airflow heater. First, to remind you of how a warm air system works, let's briefly look at what it consists of. There is a plenum on which the heater stands, a filter situated in the top of the heater above a fan, and a burner encased in a heat exchanger. A flue outlet from the heat exchanger discharges combustion gases to the outside air. The distribution ductwork includes short ducts, leading to low sidewall registers, and extended ducting, leading, for example, to the loft from where the heat is circulated through ceiling diffusers. In order to allow proper circulation, it is important that with all systems, relief air is taken from most rooms other than kitchens, bathrooms, toilets and showers, ideally through grills fitted above doors, and returned to the heater via a main return air grill in the hall or landing, which for safety reasons is connected to the heater. When the system is working correctly, the right amount of warm air is delivered to each room. But often some rooms are too hot, whilst others are too cold, and so some adjustment is needed. Before any work is carried out, the following 3 safety checks must be made. Safety check number 1. Make sure that open flue appliances have a direct return air duct. This prevents the risk of air being drawn from the heater compartment and interfering with flue performance. If there is no return air duct, there could be a potentially dangerous situation. Appropriate steps should then be taken. Safety check number 2. Ventilation of the heater compartment. Warm air central heating units are no different to any other open flue appliances as far as the ventilation requirements are concerned. They should be treated as such, and you should refer to your ventilation requirement chart for the correct procedure. Safety check number 3. It is very important to check that all return and relief air openings are free from obstruction, for example, wallpaper or pictures, as this can prevent the airflow circulation throughout the heater and whole property. Removal of the obstruction is a simple and easily overlooked remedy to a problem system. To ensure the maximum heat efficiency of warm air central heating to keep out that cold, checks on the heater appliance itself are needed. These are known as the 3 Fs: filter, fan, and fuel input checks. The filter must be clean, or the dirt will restrict airflow and bring the limit switch into action. Is the fan working? Is it clean? If the blades are dirty, it will not move the air and will restrict airflow. On basic controlled heaters, adjust the fan speed to give a temperature rise across the heater of approximately 50 degrees centigrade. Finally, fuel input. For this, check the burner pressure is set as specified by the manufacturer to give the correct heat input. If the 3 Fs, filter, fan, and fuel input are correct, and the system is still not working efficiently, there could be a simple fault on the distribution system itself. If the customer complains of some parts of the room being too cold, it means that the air is not being distributed evenly. Find the low or high sidewall registers and check that the air is not being directed into the adjacent wall, for example. If the customer complains of cold feet, it means that the low sidewall register has been installed upside down. You should remove the register and refit it correctly. The lever should usually be on the left. The rear vanes should direct the air downwards, while the front vane should be adjusted to ensure full and even distribution. Finally, a problem can be caused with either heater if there is a mixture of short and long ducts in the distribution system. Rooms fed by short ducts tend to overheat, while other rooms are too cool. The solution is to install multi-blade dampers behind registers in short ducts. These dampers are available from ducting or some heater manufacturers. If, on the other hand, upstairs rooms overheat, look for a lockable volume damper in the rising duct. To summarise, if warm air central heating is not working efficiently, you first need to carry out the 3 safety checks before you do any work. 1. Make sure that open flue appliances have a direct return air duct. If there isn't one, there could be a potentially dangerous situation. 2. Make sure that the ventilation of the heater meets the safety requirements of the industry. 3. Make sure that all return and relief air openings are free from obstruction, for example by wallpaper or pictures. You may then check the heater. Remember the 3 Fs: filter, fan, and fuel input. The filter must be clean. The fan blades must be clean, and the fan speed set on basic controlled heaters. Fuel. Check the gas rate. If the heater is working correctly, check the distribution system for possible problems. Make sure that the vanes on the low or high sidewall registers are directed for maximum heat distribution. The rear vane should be directed downwards, while the front vane should ensure the heat fills the room evenly. Check that the registers have not been fitted upside down. If there is a mixture of short and long ducting in the system, install multi-blade dampers behind the registers in short ducts. All these simple checks will go a long way to ensuring that all the rooms are warm and evenly heated. However, if the system is still not working efficiently, replacement heaters are easily available and can be installed with minimum disruption. The full comfort value of the warm air central heating system can then be appreciated by the customer. This quality, along with the quietness of the heater fan when in operation and the economic use of fuel, makes warm air central heating the obvious choice when deciding how best to keep that winter chill out. Balancing a warm air central heating system correctly will ensure that the right amount of warm air is delivered to each room in a property, rather than some rooms being too hot and others too cold. Just a Load of Hot Air Part 1 dealt with the safety, appliance and distribution checks that must be carried out before balancing the system can take place. It is very important that these checks are carried out on each visit, and it is strongly recommended that the first part of this series is studied before going on to balancing proper, which will be shown here. Later on in the programme, you will have the opportunity to practice working out balancing velocities with the support of your trainer, who will pause the video to give you time to calculate your example. To balance a system, you will need an air vanometer, a screwdriver, a thermometer, if balancing a basic controlled heater, and your balancing procedure sheet. A non-permanent marker pen and a calculator will help you do your calculations more quickly. However, Before you begin balancing, you must first make sure that all the relief air openings in the property are the correct size for the room. As a rule of thumb, this should be 10% greater than the discharge register. For example, 100 square centimetres up to 110 square centimetres, or you will be wasting your time. It is recommended that relief air openings should be at high level with low level distribution, or at low level with high level distribution. Secondly, set the speed of the heater fan to maximum and let it run. On some modulating controls there is a switch labelled continuous to allow this. On other heaters, it will be necessary to short-circuit the fan switch and select the fan speed to maximum. Carry out the velocity measurements with the fan running, but the main burner off. Thirdly, partly close the balancing dampers of the registers nearest to the heater and fully open those further away. You can then work out the guide design velocities for each room, using the balancing procedure sheet. To do this, note down the room in column 1. For example, the hall, and the heat required in column 2. For example, 1.7 kilowatts. To calculate the heat requirement for a room, use the following rule of thumb. First, calculate the room volume in cubic meters. In our hall, for example, with a height of 2.5 meters, a length of 5 meters, and a width of 2.72 meters, the room volume works out to be 34 cubic meters. Multiply this by 50 watts, and then divide by 1,000 to give kilowatts. So, 34 cubic meters times 50, divided by 1,000, gives 1.7 kilowatts. This rule of thumb is given on your balancing procedure sheet. Back to working out the guide design velocity of the hall. In column 3, write down the size of the register. Standard sizes are given on your balancing procedure sheet, and the correct air velocity factors are listed next to them. Note down the appropriate one in column 4. For example, a register 200 mm by 150 mm has an air velocity factor of 0.75. Then calculate the velocity of the air through the register in meters per second by multiplying column 2 by column 4. So, in our example, 1.7 kilowatts times 0.75 equals a guide velocity of 1.27 meters per second. Record this in the last column. This is then the correct velocity for the size of that register. Repeat this procedure for all the registers in the property. Turn over the balancing procedure sheet and enter these results in column A, noting down the number you have allotted to each register and the room they are in. Next, measure the actual velocity of the air at each register and record these in column B. For example, in the hall our reading came to 1.3 meters per second and in the lounge 1.2 meters per second. Then, for each register, divide the actual measured velocity, column B, by the guide velocity, column A, and enter the result in column C. So, for the hall, 1.3 divided by 1.27 equals 1.02. And for the lounge, 1.2 divided by 1.36 equals 0.88. Add up the results in column C, 1.9, and find the average by dividing by the number of registers in the property, for example 10. But for our demonstration purposes here, 2. Therefore, 0.95. Then multiply each guide velocity, column A, by this average, and you will have the new balancing velocities. Enter these in column D. So, in our example, the new balancing velocity for the hall is 1.2 meters per second, and 1.29 for the lounge. With these new figures, you can then balance the system by adjusting the balancing dampers and registers if necessary. When you have finished, switch the fan speed controller on or reconnect the fan switch. Light the main burner and adjust the burner pressure to gain the output required. To summarize, having completed your safety, appliance and distribution checks, make sure that all relief air openings are the correct size for the room. Then set the speed of the fan to maximum and let it run at this speed. On basic heaters, short-circuit the fan switch and set the fan speed to maximum. Carry out the velocity measurements with the fan running but the main burner off. Partly close the balancing dampers of the registers nearest the heater and fully open those further away. For practice, you will now calculate a new balancing velocity based on figures that will be given to you shortly. Your trainer will pause the tape in order to give you time to do the necessary calculations, and after a short period, the correct answer will be given. You will need a non-permanent marker pen and calculator. Now pause the tape to prepare. Welcome back. We are now going to calculate the balancing velocity for a bedroom. The heat required in the bedroom is 1.3 kilowatts. And the size of the register is 200 millimeters by 100. Now, multiply the heat required by the air velocity factor. You now have the correct guide velocity for the bedroom. That is, 1.48 meters per second. Fill in the first 3 columns in the chart over leaf. To continue, the measured velocity of the bedroom register is 1.75. Don't forget there are 3 registers in total now. The new balancing velocity of the bedroom is 1.5 meters per second. Remember, you would then need to recalculate the other rooms based on this new average. Adjust the balancing dampers or registers as necessary to meet the required velocity. Room temperature should be adjusted to suit the particular requirements of the householder, or should be evenly distributed around the property, rather than rooms nearest the heater receiving most of the warm air. This will increase customer satisfaction and reduce the number of callbacks. As service engineers in daily contact with the customer, it is important to realize the market opportunity of replacing old, worn-out warm air heaters. Modern heaters are efficient, quiet, and give superior comfort levels, and water heaters are usually incorporated. The quick and easy job of replacing or upgrading old heaters can be more convenient and economical for the customer, as well as profitable for the company. It can also offer favourable incentives to you, the service engineer.